The question we are solving now belongs to test series 6. It is of control system subject. In specific, it belongs to Routh analysis. As per the question, there is a closed loop control system as shown in the figure. It contains a unity negative feedback path, and in the forward path, it contains a PD controller which is of gain Kp plus Kds, and the forward path transfer function which is present after the PD controller is 10 divided by s square. Please note that the input to the system is R of s and the response of the system is C of s. We need to find the condition on Kp and Kd for the system to be stable. From the given data, we see that the transfer function of the network T of s is equal to C of s divided by R of s can be written as Kp plus Kds multiplied by 10 by s square divided by 1 plus Kp plus Kds multiplied by 10 by s square. This is due to the reason that h of s is equal to 1 and g of s is equal to Kp plus Kds multiplied by 10 by s square. Upon simplification, we see that the characteristic equation of this closed loop control system can be written as s square plus 10 Kds plus 10 Kp is equal to 0. So now upon performing the Routh analysis on this, we see that the Routh array can be found as shown. It contains the entries in the first row as 1 and 10 Kp and the entries in the second row as 10 Kd. So from this we see that the entry here can be written by filling the Routh array by using the Routh array concept as 10 Kp. We know that for the system to be stable, the number of sign changes in the first column should be equal to 0. As the first element is always positive, we know that for the system to be stable, the second and third entries in the first column should be positive. This implies Kd should be greater than 0 and Kp should be greater than 0. From this we see that for the system to be stable, both Kd and Kp should be positive. From this we can say that the correct option which gives the conditions for the stability of the given system is C.